Hello, in this tutorial I will tell you about strings in Python. Generally in computer programming, a string is a sequence of characters, and its purpose is, for example, to read from files or to write output files, to read user input and write output to the user. Let's start IPython for Python 3 and have a look what you can do. We can define strings in three different ways. We can start them with a single quote, hello world, or we can do the same with a double quote. And the purpose of having each possibility is if you need to have a single or double quote in the string, you can simply type it. Say here I can type hello double quote world, for example, and it works because the string is delimited by the single quote here and here, so I can use the double quote here as a regular character, no problem, and the other way around as well. So here I have double quotes as delimiter and a single quote here in the middle. This still works. But what if I need to have single quotes and double quotes? Then I have two options. One of them would be, here this doesn't work, one of the options would be to escape the double quote. That would mean having a backslash in front of the letter I want to escape, so it's not taken as a quote to end the string, but as the sign inside the string. So this here would work, for example. Or I could delimit the string with three consecutive quotes. So I can say hello, and then I can do whatever I want in single and double quotes inside, and it will still work. I can even do new lines inside of the string here. Let's say hello world, this is great. Okay, and Python stores the string having the new line character, which is an escaped n. Now we can store this string in a variable. Let's say s for string is hello world. Now what can we do with these strings? We can add strings together. For example, I can say s plus and then add a new string to it. Let's say an exclamation mark, and this is great. This adds the two strings together, which is also called concatenation. This is the first string and this is the second string. We can also multiply strings, s times 3, which simply concatenates the string s to itself 3 times. So we've got hello world, and again hello world. If you want to access a part of the string, we could type s square bracket and then the letter we want to access. For example, 2. And which letter will we get? We'll get the L. But why is that? Why don't we get E? Because indexing starts at 0. This has a history in computer programming. Initially, a string was essentially a list of characters, and the string variable was a pointer to the beginning of the string. And so S0 would be the first character, which is the beginning of the string, and S2 would be the beginning of the string plus 2. So the beginning of the string plus 1 and 2, so we would get the L at S2. And we can also, of course, access S1 and everything else, but we can also access the back of the string, say S minus 3, which is the third from the back. That would be the R character. And S minus 2, as well as S minus 1, which is D here. If you would do S minus 0, minus 0 would evaluate immediately to 0, so we would get the H again. And there it is. Now we can also do slicing. Slicing is giving you a part of the string, but it's actually a copy of that part. Say we can do S1 colon 3, which gives us the character after the first character and until before the third. So if I print string before, we get it from here, from before 1 to before 3. And we can also say s:3, which means from the start of the string to before the third, or the other way around, s3: from before the third to the end of the string. Finally, we can of course do the same with negative indices. That means I can do s:-3, which means from the start of the string to 3 before the end. I do s again, so you see the last 3 are missing. And then we can also get parts of the string. Let's say we want from the first character, not the first in the string, but the one with the index 1, until 3 before the end, but not every one, but every second character. So we get the E, the L, the space, and the O. That's slicing. And if we take such a slice, I call it slice equals this slice here, slice. This is a copy of that part. Now that's something that's very important. Strings are generally immutable, so we cannot change an existing string. I cannot say s3 equals another character, let's say t. Python will end this with an error. And there it is, it's a type error. String object does not support item assignment because it's not mutable. And that also means that this slice here, I cannot change the slice. So by having a slice, I cannot change the string either. So I cannot do slice 3 trying to change the string, or slice 3 is t trying to change the string, because I cannot even change the slice. We can also look at how long a string is. Let's print out L again. The length of a string is denoted by len of it, and length of the string is 11. So that means we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have positions 0 to 10, which is 11 characters. We can never access the length of the string, so we can never access the 11th. Because we start at 0, we have to end at 1 minus the length. So the last character would be len of s minus 1, but that's a bit complicated to type, because we can simply say s minus 1 to be sure. Now, there are a few functions, things you can do with strings. You don't have to memorize these. IPython helps you. So I can just say s dot and use the tab key in IPython, and IPython will tell me which functions are available for strings. There are plenty different ones. Let's have a look what's common. For example, upper would create a new string which is uppercase. It does not change the existing string. So I do s.upper : and I get a new string which is all uppercase, and the original string is still the way it was. It's still lowercase. Now, if we don't know how to use such a function, and I'm not going to demonstrate all of them because there are plenty, we can use the help which comes in IPython. So I can say s.find and the question mark at the end, and IPython will show me return the lowest index in S where substring sub is found. So let's say s.find and enter a substring, let's say world, and will tell me where in the string S the string world occurs. It starts in position 6. 0, 1, 2, 3, 4, 5, 6. World exists and starts at position 0. Where does the character H occur first? It's in position 0. And where is the string boom? It's not in there, so s.find returns -1. You can also split the a string into a list. For example, if you're reading an input file and we get a list of names, let's say John Doe and Jane Q Citizen and Joe Soap, for example. And we want to split this into 3 separate strings, each containing one name. We can say s.split, and if we don't know the exact syntax, we can again use the help with the question mark, and says the separator primarily is none, so it would separate the string on white space. We can try that out. s.split, and we get a list of plenty of strings, not just the names but first names, and then we have the commas inside. This is definitely not what we want. What we want is to split the string, add a comma followed by a space. S.split. Now we have John Doe and Jane Q Citizen and Joe Soap in a list. Then there's an idiom which does essentially the inverse. So if we have a list, L is this list of strings. If we have a list and we want to write this to a file, and we want to concatenate this so we have a single long string, we can just say take a string and join this list together. And this is the character that's used to combine these strings here together. At the moment it's an empty string, so these 3 strings will be combined as they are. So I get John Doe with nothing in between to Jane Q Citizen and nothing in between to Joe Soap. If I want to have some delimiter, I can, for example, use a comma. Then I have John Doe, Jane Citizen and Joe Soap, or anything else, which is fairly common. That's already the end of this tutorial. I hope you can benefit of it and have fun programming Python. Hello, this screencast demonstrates the Python 3 format string syntax. We'll start the IPython3 shell, and despite the Python 3 format string syntax is, in my opinion, the best way of formatting string output, we'll still start out by showing basic ways that string formatting could be done in the past. So we could have written value colon and then %d, and the %d was replaced by an integral number, and the number in this case is 3. So the 3 will be used to replace this %d, and the string here is separated with a percentage sign. We could use the same, of course, with multiple variables, say x colon %d, y colon %d, and in this case multiple variables have to be put into a tuple, 3, say -1, and hit enter, and 3 is used for the first %d and the -1 for the second %d. You could also use the print function to say value colon, not put a space here, but say a comma, and the print function will print one argument after the other. So it will first print the value string, then it will insert a space, and then it will print this here converted to a string. So it will also print value colon 3, or we could store the result of combining a text value with an integer. Here I need the space again. I cannot simply add an integer to a string, but I have to convert it to a string first, so I still get the same result, value colon 3. This is how string formatting has been done in the past here and there, and I highly recommend using the new format function, which is nicely documented in the official Python documentation, which is also where I got most of my examples from. I will use copy and paste so I can save myself some typing. Here we have print, then we have in curly braces. This is the first argument. This is the second argument to be replaced, and this is the third part to be replaced. The string is this here, so it's delimited here and here, and now we use this string's format function, call.format, and the first argument of the format function will go into the first curly braces here, the second one into the second, which is already clearly marked by the index 1, and the last argument will go into the curly braces with the index 2. Let's print this ABC. This is just as we would expect it. We can also store the result of this in a variable. So we can simply use exactly the same as above, the string here and its format function, and assign it to a variable. Doing this, print text, and it's still what is expected. If we want to use the parameters in the order they are specified in the format function, we can save ourselves some typing and don't have to add the 0, 1 and 2 here. So we can simply use curly braces, and curly braces, and the first pair is replaced by the A, the second pair by the B, and the third pair by the C. Let's print it out, and it works nicely. We can, if you want to, however, use the numbering in the curly braces to change the order of the arguments. Say in this case, the last argument at index 2, the C, will be replaced here, the B will be in the middle, and the A will be last, because the A is the first argument here and it has the index 0 here. Let's print this, it's CBA. And we can also use the arguments more than once. So in this case we have 0, 1 and 0, so 0 is Abra and 1 is going to be replaced by this, and the 0 will be replaced again by this, and surprise, it's going to be Abracadabra, which is yet another example I got from the official Python documentation. But one thing I believe is even nicer is that instead of using numbers here, we can use names and keyword parameters. We'll delete my screen here with Ctrl L. Up. And let's have a look at a first example. Here I have a string, and the string starts here. The string starts here and ends here. And the first curly braces has a keyword latitude and the second longitude. And the format function now has to specify keyword parameters. The first parameter here, latitude, defines a string, and this string here, the 37.24n, will be replaced here, and the longitude one, this one here, will be put here. And now of course the order of the arguments does not matter anymore. Let's have a look, and it's just what we would expect here. Now we can also use an own dictionary if you already know how to work with these. So we can define a dictionary by starting curly braces here and ending them here, and the dictionary has two pairs. It has latitude is 37 and longitude is -115.81 west. And now we can use a slightly more compact form for printing a string. So we can now use coordinates is latitude, longitude, and instead of typing the keyword parameters, we use dictionary unpacking. That means we use the dictionary coord that we defined here, and the 2 stars here means unpack the dictionary so that each pair here is going to be a keyword parameter. So the first pair will be keyword parameter latitude set to this value, and the second will be keyword parameter longitude set to that value. So we get exactly the same output as above. And one thing I really like for debugging and printing out different local variables is that we can use a function called local, which returns as a dictionary with all kinds of local variables. I'm defining a few here. So latitude is set now, and longitude is set as well. And now I can do the following. I can say coordinates is, and then the first one is latitude, the second one is longitude, and here I use this locals function, which returns me a dictionary with all the local variables. This dictionary is unpacked, and so I get a series of keyword parameters, among others latitude set to this, longitude set to that, coord set to this, but all the keyword parameters not used by these curly braces will be silently discarded. So I can use this and it works as well. Then I can do all kinds of formatting, but I really encourage you not to learn everything by heart. Just look it up in the Python documentation when you need it. So here we have curly braces, and here we add some formatting detail that says make a 30 character wide string and right align it. So this text here will be right aligned in a 30 character long string, and that's what happens here. Of course I can also center or left align it. Here is an example for centering. I replace the right align character, this one here, with the centering character, and it also works as expected. I'm cleaning my screen now with Ctrl L. One other thing we can do is we can use numbers in different formattings. If you're doing computer science, you're probably into hexadecimal numbers, octal numbers, binary numbers, and so on, and Python can nicely print them by simply specifying one format character. $X means hexadecimal, $O means print the number as octal, and $B means print the number as binary. Now I hit enter, and the number 42 will first be printed as decimal and then as hexadecimal, octal, and binary. There it is, 42, and here we got it as hex value, as octal value, and as binary. However, if we want the hex values marked with the leading 0x or the octal with the 0o, we have to add a number sign before the x or a number sign before the o. If you now print this, we'll get 0x2a or 0o52 and 0b for binary. Now let's move on to formatting dates and times. I'm importing the datetime library, and I can use the datetime library, and this is now a very simple example. Here I'm formatting datetime now, which is this time, this day, and it will be as a whole formatted in the first parameter here. So this is today when I recorded this, and of course I can add some specifiers to say how I want this to look. For example, I can say colon and then %y is year, month, date, and only the year, month, date part of the datetime now will be used. So I get 2014-07-07. If you're doing math, you're probably having to do a lot with complex numbers, and let's define one here. Say complex number 3 minus 5j. Now we can print a complex number in different ways. We can print the complex number as a whole. This is what I'm doing here. The complex number will be printed as a whole here, but I can also print only the real part by saying first argument dot real, or only the complex part, the imaginary part, by saying oh, this didn't work. Let's do the same again. So the real part and the imaginary part is .imag. Now let's format this. This is the whole number here. The real part is only the 3, and the imaginary part is only the -5. I can also access parts of a tuple. Let's define a tuple coord equals 3, 5, and print out the tuple. So here we access the tuple's first value as take the first argument's first value, simply indexing the tuple, and here index the tuple again to access the 5 of the tuple. The same also works for dictionaries. I'm defining a simple dictionary now, containing 2 keys, Y for yes and N for no. And if I want to access parts of the dictionary, I must be careful. I'm not using string delimiters. I simply use the key right away here. So I use square brackets and the key. So I will get, instead of this argument, I will get the yes string here, because the first argument is this dictionary, and of this dictionary I take the Y key. And yes, that's what it is. And I can also use somewhat more complex resolutions. I can, for example, access object members. Let's define a very basic object, self xy, self.x, comma self.y equals x comma y, and another function def string of self return. So now here what I'm doing is I set the keyword self to self, which represents the current object. Now I can access all of the object's members by saying self.x or self.y in the string formatting function here. Let's test this out. Show me a string of point 5 comma minus 3, and we get 0.5 comma minus 3 because self.x is the 5er and self.y is replaced by the minus 3. Now this is the end of this tutorial, and remember that most of the examples were taken from the official Python documentation, and it's really worth having a look. And I'm going to show you where the examples come from. It's from docs.python.org/3 for Python 3, and then library, string, and so on and so forth. I'm opening this here. I exit IPython, and we'll open this in a small browser. Now here you see just the examples that I entered up there. Have a look at this documentation, docs.python.org/3. This is the end of the screencast. Have fun putting your new knowledge into practice.